A company which make battery-operated cars claims that its products have a mean life of span 20 years with a standard deviation of 50 years. If a random sample of 40 toy cars was tested and found to have a life mean of only 25 years, test if the sample is a representation of the population at 0.01 level of significance. Step 1. Identify the null and alternative hypothesis in this problem. The null will be equal to 20 and the alternative will be not equal to 20. Step 2. Now we will identify the levels of significance and identify if this problem is in one-tailed or two-tailed test. As you can see in the problem, the level of significance is already directly stated, which is 0.05. Next, we are going back to alternative hypothesis and check what mathematical symbol we used. So in this problem, we used not equal symbol. So this problem is under two-tailed test. Step 3. Since the sample and the given problem is 40, we are going to use one sample z-test. Step 4. The population mean will be 20 years. Next is the number of sample, which is 40. And the sample mean will be the 25 years. Last is the sample standard deviation, which is 50 years. Next, we have to use the sample standard deviation formula, substituting the value 25 minus 20 over 50 over the square root of 40, which is equals to 4. So the value of our z computed is 4. Step 5. Since we already have the z computed, we are now going to find the z tabular. We are going back to step 2 and identify the level of significance. Here we have 0.01 and the two-tailed test. And we are just going to find it in the table, which equals to 2.58. Now we are going to substitute the values. The z computed will be 4 and the z tabular will be 2.58. Step 6. We will identify if we have to reject or fail to reject the values. Now we will go back to step 5. We have to check if the given inequality is true or false. It says that 4 is greater or equal to 2.58, which is true. So we're going to reject the null hypothesis. Step 7, we have to conclude based on step 6. Since we reject null hypothesis, we have to stick in our alternative hypothesis. So now it will be the products in a company does not have a mean lifespan of 20 years. A coffee shop relocates to Italy and wants to make sure that all lattes are consistent. They believe that each latte has an average of 22 ounces of espresso. If this is not the case, they must increase or decrease the amount. They took a random sample of 10 lattes and the following are the ounces of espresso. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Use alpha 0.05. Step 1. Identify the null and alternative hypothesis in this problem. The null will be equal to 22 and the alternative will be not equal to 22. Step 2. Now we will identify the level of significance and identify if this problem is in one-tailed or two-tailed test. As you can see in the problem, the level of significance is directly stated, which is 0.05. Next, we are going back to alternative hypothesis and check what mathematical symbol we used. So in this problem, we used not equal symbol. So this problem is under two-tailed test. Next is the degrees of freedom. And the formula will be n minus 1. In our problem, the value of n is 10. So substituting n to 10, 10 minus 1 is 9. And 9 will be the degrees of freedom. Step 3. Since the sample and the given problem is less than 30, so we are using one sample t-test. Step 4. The population will be 22. Since they did not give the sample mean and the sample standard deviation, and what we are given is the raw scores from the sample. First, we must identify the number of samples we have, and that is 10. Since we have 10 numbers available, Then for the sample mean and the sample standard deviation, we will compute it since it is not given directly. First is to press mode and then press the number equivalent to stat, which is 3. And then press the number equivalent to 1 minus var, which is 1. And then this will be displayed in your calcu. Next is to input all the x values given in your problem. So by pressing the number itself and equal sign, and then proceed with the next number until you finish with all the x values. So the values will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and last is 10. After that, you have to press on. This will be the display, and then we have to look for the function stat in your calcu. And since it is in the second function, you press shift and then stat. After that, we're going to choose var, which is 4. After you press var, we have to look for the x, which is 2, and then equals 5.5. This will be our sample mean, and then press on again. For the sample standard deviation, you press shift and then stat and then var. After you press var, you're going to choose SX, which is 4, and then press equal sign. That will be our sample standard deviation. Now we have all the values. We can now compute for the t computed. And since this problem is under one sample t-test, we have to use the formula for one sample t-test, and that is the sample mean minus the population mean all over the sample standard deviation all over the square root of n. Substituting the values, we will have 5.5 minus 22 over 3.03 over square root of 10. We will have negative 17.22, and that will be our t computed. Step 5, since we already have the t computed, we are now going to find the t tabular. We are going back to step 2, and first to find the degrees of freedom in the column. After finding the numerical value, draw an imaginary line passing through the freedom. And since it is under two-tailed test, we are going to look at the two-tailed test. And the intersection of those two imaginary lines will be our t tabular. Now we have the values. We are going to substitute the values. It will be negative 17.22 is greater than 2.262. Step 6, we will identify if we have to reject or fail to reject the null hypothesis. Now we will go back to step 5. We have to check if the given inequality is true or false. It says that negative 17.22 is greater or equal than 2.262, which is false. So now we are going to fail to reject the null hypothesis. Step 7, we have to conclude based on step 6. Since we failed to reject the null hypothesis, we have to stick in our null hypothesis. So now it will be the latte in the coffee shop are consistent. The school registrar estimates that the dropout rate of senior high schools in Cavite is 80%. Last year, 20 freshmen from a random sample of 40 Cavite Senior High School withdrew. At 0.05, is there enough evidence to reject the registrar's claim? Step 1, identify the null and alternative hypothesis in this problem. The null will be equal to 0.80 and the alternative will be not equal to 0.80. Step 2, now we will identify the level of significance and identify if this problem is in one-tailed test or two-tailed test. As you can see in the problem, the level of significance is directly stated, which is 0.05. Next, we're going back to the alternative hypothesis and check what mathematical symbol we used. So in this problem, we use not equal symbol, so this problem is under two-tailed test. Step 3, since the problem is under proportion, so we are using z-test for proportion. Step 4, we must identify the given values first before we solve. The sample proportion will be in the second sentence in this problem. Now we have our x as 20 and the total number of samples is 40. For the sample proportion, we have 20 over 40. Now we have to rewrite the fraction form into its decimal form so that we can solve easily. So 20 divided by 40 is the answer is 0.5. Next is the population proportion, which is equivalent to 0.80. In this problem, next is the value for the Q with formula 1 minus P. Substituting the value, we will have 1 minus 0.80. Simplifying the value of Q, which will be 0.2. Now that the values are complete, we can now substitute in the given formula for Z computed. Substituting 0.5 minus 0.80 all over the square of 0.80 times 0.5 all over 40. The value for our Z computed is -3. Step 5. Since we already have the Z computed, we are now going to find the Z tabular. We are going back to step 2 to identify the alpha level and the number of tail tests. So this problem, we have to take the alpha level as 0.05 and we have two tail tests. Now we are going to make an intersection in two tail tests, and in 0.05 it is the value of the Z tabular, which is 1.96. Step 6, we will identify if we have to reject or fail to reject the null hypothesis. Now we will go back to step 5. We have to check if the given inequality is true or false. It says that -3 is greater than or equal to 1.96, which is false. So we are going to fail to reject the null hypothesis. Step 7. Now, in step 7, we have to conclude based on step 6. Since we failed to reject null hypothesis, we have to stick in our null hypothesis. So now it will be, there is enough evidence to reject the registrar's claim. Given the following data about 6 patients, determine its correlation coefficient. Step 1, identify the null and alternative hypothesis in this problem. As you can see, in the given problem, the degree relationship is not stated. So, automatic, the null will be equal to 0 and the alternative will be not equal to 0. For the statement form of null, we have there is no significant relationship between the age and the blood sugar level of the patients. And while for the alternative, there is a significant relationship between the age and the blood sugar level of the patients. Step 2, now we will identify the level of significance and identify if this problem is in one-tailed or two-tailed test and the degrees of freedom. As you can see in the problem, the level of significance is not directly stated. So if it's not stated, automatically it will be 0.05. Next, we are going back to alternative hypothesis and check what mathematical symbol we used. So in this problem, we use not equal symbol. So this problem is under two-tailed test. Next is the degrees of freedom. And the formula will be n minus 2. In our problem, the value of n is 6. So substituting n to 6, 6 minus 2 is 4. And 4 will be the degrees of freedom. Step 3. Since the given problem are looking for relationship for two variables, we are using person R correlation. Step 4. We have, first is to press mode, and then stat, and then a plus bx. After pressing a plus bx, we're going to put the x values, which is 17, 22, 28, 33, 39, 46. After getting the x values, we're going to put all the y values, which is 72, 86, 89, 74, 96, and 91. After getting all that, we press on and then shift 1, and then we're going to sum. We're going to find the summation of x, which is 2. So x is equals to 185. And then on shift 1, sum, we're going to find the summation of y, which is 4. Now the value of the summation of y is 508. Next is to find the summation of xy. So xy is 5. 5 equals to 15,980. So next is to find the x squared, the summation of x squared. So x squared is 1, 6,283. Next is to find the summation of y squared. So y squared is 3. It is equals to 43,474. Now that we know the values of the summation, now we can substitute it for us to get the value of R computed. So substituting the values, we have 6 times 15,980 minus 185 times 508 all over the square root of 6 times 6,283 minus 185 squared times 6,434 minus 508 squared. Since the amount of numbers is big, we are going to solve it by numerator and denominator. In the numerator, we have 1,900. And for the denominator, we have 3,107.24. So dividing the two numbers, we have 0.61 as the value for R computed. Step 5, since we already have the R computed, we're going to find the R tabular. We are going back to step 2, and first to find the degrees of freedom in the column. After finding the numerical value, draw an imaginary line passing through that freedom, and since it is under two-tailed test, we're going to look at the two-tailed test. And the intersection of those two imaginary lines will be our T tabular. Will be our R tabular. Now we have the values. We are going to substitute the values. It will be 0.61 is greater than 0.8114. Step 6, we will identify if we have to reject or fail to reject the null hypothesis. Now we will go back to step 5. We have to check if the given inequality is true or false. It says that 0.61 is greater or equal to 0.8114, which is false. So we are going to fail to reject the null hypothesis. Step 7, we have to conclude based on step 6. Since we failed to reject the null hypothesis, we have to stick in our null hypothesis. Now the statement will be, there is no significant relationship between the age and the blood sugar level of the patients. Now to verify this, we have to check the degree of relationship for this problem. Since our R computed is 0.61, it will fall into the range of 0.50 to 0.70. And the interpretation is moderate positive negative correlation. Since the R computed is positive, we are using the moderate positive. Now we have the final conclusion, which is there is a moderate positive relationship between the age and the blood sugar level of the patients. Given the values below, predict the grade of a student in math if his grade in English is 93. Since we are predicting the value, therefore, this problem is under regression. Now we're back in the calculator again. We have to press mode and then stat and then a plus bx. First, we're going to put all the values of x. After putting the values of x, we are going to put the values of y. After putting all the values, you have to press on and then shift 1 stat and then sum. After pressing sum, we have to put the summation of x, which is 2, 885, and then shift 1 sum the summation of y, which is 4. So the summation of y is 881, and then shift 1 sum the summation of xy, which is 5, 78,107, and then shift 1 sum summation of x squared, which is 1, 78,925, and then shift 1 sum the summation of y squared, which is 78,137. Since we have identified the values, we can now solve for the intercept and for the slope. Here's the formula, and we have to substitute the value. Substituting it, we have 881 times 77,205 minus 872 times 77,137 all over 10 times 77,205 minus 875 squared. And since the amount of the numbers is big, we have to simplify the numerator first, then the denominator. Simplifying it, we have 522,730 as the numerator, and the denominator is 6,425. Dividing it, we have 81.36. Next, we have to solve for this loop. Substituting the values, we have that 10 times 77,317 minus 875 times 881 all over 10,007 all over 10 times all over 10 times 77,205 minus 875 squared. Solving the numerator first, we have 495, and the denominator is 6,425. Dividing it, we have 0.08. Now we have the values for A and B. We just have to substitute the values in the regression analysis so that we can determine the values for Y, given the value of X. In this problem, we have the given A as 81.36, and for B, we have 0.08. Substituting the values of A and B, we have it as Y is equal to 81.36 plus 0.08x. Now we can identify the grade of a student in math if he has a 93 in English. Identifying the possible grade, we have substitute the value of x as 93. Now we have y is equal to 81.36 plus 0.08 multiply by 93. Now approximate value for y if x is 93, we have 88.8 plus 0.08 times 93. We have the answer as 88.8. and we have to round it off. Now it will be 89. Therefore, we have the grade of a student is 89 in math if his grade in English is 93.